Structural Modeling 2.0, an application of basic structural modeling and interpretive structural modeling. This is our next cut at structural modeling videos. We have improved technologies and a whole new video development suite. The information is located on my website. Has a lot of background information on the structural modeling project. This is where there's documents, there's other videos from the first video series, and there is a complete archive. When you go to the front, this archive right here will take you back into all the historical data. There's a pointer to the Sage tool that was used in the first videos. This video uses a JavaScript tool. And then this is a pointer to my Twitter account where I make announcements of new videos and other types of information as it becomes available associated with a project. So let's move right on with this. So the basic structural modeling project, we're starting into the phase 2 video series. The phase 1 video series is complete. We're going to go over and develop some fundamental concepts and ideas, which we'll go over again in this video, introductory video. And I've developed a JavaScript web application that I will introduce in this introductory video here for the second series. And we'll talk a little bit about the inference operation and application, and also structural integration modeling, which is a component of structural modeling which fits between basic structural modeling and interpretive structural modeling. So the phase 1 video series had graphic grids that were created using a spreadsheet. The graphic analysis was performed manually. Matrix calculations were performed in a Sage program, and then the manual transfer of data between the Sage and the spreadsheet. So there was limited inference integration points because it was done manually, and it was used to test the video production capability. I used a Linux-based system the last time. This time we're using an Apple-based system. We'll see how it goes. It was a good start, but it really needs some improvement. So we'll see if we can do that here. The phase 2 video series, we had created a JavaScript program for automation of an integration of the activities. The graphic grid is drawn on HTML5 canvas. The matrix calculations are performed by JavaScript, and all the information is in one program, so there's no need to transfer data between one system and another. And the integration analysis is available at every step. You can just click the infer information and see if there's any new information available. And of course it's used to demonstrate the JavaScript program that is just kind of a proof of concept here, and it shows the types of systems that can be developed. So the fundamental concepts and ideas, basically what we're focusing on here is the 3 types of truth: the formal truth, the factual truth, and the value truth. And in the grid that we're using here, we're using the grid as a component of the marking space in the art form. And we are encoding formal information and factual information both in that grid. And so this approach uses the same computational system and demonstrating a computational approach with an open source tool. So we're using, of course, JavaScript, HTML5, other types of open source tools are available. The application relation type integrates with the truth operations. We're integrating the formal and factual truth into the marking space. The value truth will be used in the value space. We won't be using that much in this particular series, but that may become important later on. And of course the value space supports the value truth. And system structure, of course we need to think about what a system is and how it relates back to these components. So the types of truth, there's a formal truth, which just depends only on the logical connectivities in the sentence. You can do computation, they're certain, they have some nice qualities to them. There's factual truth, which depends on the state of the real world. Of course, then there's value truth, which can be determined in a number of different ways, but is really dependent upon the value system associated with an individual or an organization, and it really expands into ethics, culture, and prediction type of issues. So here's a chart that kind of gives an overview of these three types of truth. And what we're going to be doing is we're going to be combining the formal and factual truth into the marking space using this grid. And we'll see that the formal truth is really not known by experience, but it's certain. Factual truth is known by experience, but it's not certain. And the required data to validate inference, of course, is a proof, so you can calculate it. And observational data and predictive success are what's important in the factual area, with empirical data that's integrated and entered into the program. So we'll see this as you go forward, how these components all work. Abstract relation type, which is developed by the authors, essentially has three primary areas. It has a marking space, an outcome space, and a value space. Each of these spaces can have one or more matrices associated with them, or other subspaces associated with them, and they're used to encode specific types of information. In this case, we're going to be encoding the factual and formal truth in the marking space matrix. We'll have one matrix, and it will be in the marking space, and that's what we'll be focusing on at this time. Then the abstract relation type, which has three types of information associated with it: the prose information, graphics information, and mathematics and computer representation. The documents on the website associated with this video series details this in particular, but we're going to be working on the math area here, of course, in this computer code. And we're working with systems and system concepts. We normally work with them in two modes, either the design mode or the discovery mode. And in this specific case, we're working in the discovery mode. We know they're objects. We know we have these 19 cities, and we need to discover the relationships between and among these objects. This is a graphical type of approach. Most systems, a graphical type of approaches work in the design mode, where they use the graphics to document and communicate the aspects of the system design. So this type of graphical approach is a little bit different. So a system is a relationship mapped over a set of objects. We know the cities, those are the objects. We know the general relationship is north of, but we must discover the specific relationship between each city pair. And that way we'll have empirical data, and once we get empirical data, we'll also infer relationships from the already collected empirical data, which will help us complete the task more efficiently. And to create a Java, so the conceptual design objectives basically create a JavaScript-based ordering process, which we've done, we'll demonstrate here. We'll integrate graphic, inference, and analysis into the same program, create an integrated tool base, and of course key design considerations are maximize use of inference, minimize the use of empirical data, and minimize costs, because gathering empirical data, of course, costs money, and demonstrate the JavaScript application. So the general steps in this process, basically step one, you initialize the process, which is identify the cities, create the matrix. And then general step two, which you just loop through until you're done, is to obtain empirical data, order the structural information, infer additional information, and then goes back up to step one, which is obtain more information. And you cycle through this until you have a completely ordered system. And on the matrix, when we're integrating and using two types of truth, we have specific marking process. So this is the specific process marking types. So we're using, for formal truth, we use true and false. For empirical truth, it's either known or unknown. And we can combine these and use them on the same matrix. We're using true, false, and unknown.